Hello Year 11 and welcome to our next installment on our series work, and we're going to be talking about annuities today. Now annuities are basically when you put regularly an amount of money into some sort of investment normally. So for example, let's say you decided every year for the rest of your life up until you were age 60 you were going to put $100 into the bank at the end of every year. So $100 at the end of this year, $100 at the end of next year, $100 the year after, and so on for 60 years. Well, that would be an annuity. It's a fund where you put a certain amount of money, and you can determine what that is, and it gets invested regularly for a whole lot of years. It doesn't have to be years. You could do the annuity monthly, or you could do it quarterly, or you could do it daily. It's just a regular amount of money over a regular time period. So let's look at our examples. An engineer pays $1,000 into superannuation fund at the beginning of every year. Beginning's in red. You'll see why when we do example 3. Compound interest is paid at 9% per annum on the investment. What will be the value of the investment, that should be, or her investment, at the end of 35 years? So that's just a typo there. But before we do this, we need to know what the compound interest formula is. Well, the compound interest formula is given to us as amount is equal to P bracket 1 plus R to the power of N. Now, the first amount of money that he puts in is $1,000. The interest rate's 9%, but what's 9% as a decimal? 9 divided by 100 is 0.09, and we add that to 1 and you get 1.09. So we've got $1,000 times 1.09 to the power of 35, because this amount of money is going to be invested at the end of, at the beginning of a year, and he's not collecting it for 35 years, so it'll get 35 years worth of interest. So it's $1,000, the 1.09, because our interest rate is per year, because we're doing this yearly for 35 years. Now don't bother calculating what that is. Leave it like that. Don't put that into the calculator. You'll see why in a moment. The second amount of money, he puts in $1,000 again. This is at the beginning of the second year. Still going to earn 1.09% interest. The 1% is the original amount, the 9% is the increase. For this amount's only going to earn 34 years worth of interest. Don't figure out what that works out to be in the calculator, leave it like that. The third amount, it's still $1,000, still 1.09, but he's only going to earn 33 years worth of interest because 2 years have elapsed. There's only 33 years left after 2 years have gone. Follow that pattern through. What would he earn on the 35th payment of $1,000? Well, $1,000 goes in, 1.09. He's only going to earn 1 year's worth of interest. The beginning of the 35th year, he's going to earn 1 year's worth of interest because he's collecting it at the end of the 35th year. So there's his amount. So how much money does he get altogether? Well, he gets that payment, that payment, that payment, all the way through to the 35th payment. So there's 35 separate amounts. So the total amount he's going to get is his first payment, or first amount, and second amount, and third amount, and all the way up to the 35th amount, all added together. So we can write them down now as 1,000 times 1.09 to the power of 35 plus 1,000 times 1.09 to the power of 34 plus 1,000 times 1.09 to the power of 33, all the way down to 1,000 times 1.09 to the power of 1. Now here's the trick. This will make life a lot easier if you listen to this step. Rewrite all of that in reverse. Now technically you probably could have just done it first up, gone A35 plus A34 plus A33 down to A1, but write it in reverse. The reason we want to write it in reverse is because I'm going to be generating a geometric number pattern, and we like to start with the small numbers first because we keep A small and we keep R with a positive power in this case. Now you can see every term has 1,000 involved in it, so we'll take out 1,000 as a common factor, and what we're left with is all of our 1.09s. Inside that square bracket is a geometric statement. It's geometric. Now we know A is 1.09 to the power of 1, which is just 1.09. We're multiplying every term by 1.09 to generate the next term. So R is 1.09. We're going from 1 to 35, or 35 years worth, so there's 35 years. N is 35 years, 35 payments. Just a reminder that that there is our formula for the sum of a geometric number pattern. So I'm going to use this formula on the square bracket. So we'll get the 1,000 out the front, multiplied by our sum formula for our square bracket. So we get 1,000. A is 1.09. R to the power of n is 1.09 to the power of 35. Take 1 over R, take 1. Put that into your calculator and you end up with $235,124.72 if I round it to 2 decimal places, so I've got it to cents. Now, let's just think about this logically for a second. He put in $1,000 on 35 different occasions. That works out to be $35,000 that he put in. Yet he ended up with $235,000 and a bit. So he's actually earned $200,000 in interest. That's not a bad effort, and that is the power of superannuation when you're earning interest on your interest on your interest on your interest. It's incredible the way it can grow. So the second example is almost identical to the first example. We're doing it for practice. So let's have a look at it. The man's putting in $750 instead of $1,000 at the beginning of each year in a superannuation scheme. The interest paid each year is 8% per annum, so 8% per year, compounded annually, so that means yearly. How much will his investment be worth after 20 years? So we're doing everything yearly. Remember, 8% is 8 divided by 100, which is 0.08 as a decimal. So the first amount will be $750, 1.08 when we add the 1 and the 0.08 to the power of 20, because he's putting this in for 20 years. The second amount, $750 again, 1.08 again, but he's only getting 19 years worth of interest on that second amount of money. The third amount, $750 again, 1.08 again, but now he's only going to earn 18 years worth of interest. We didn't calculate those amounts because we're just looking for patterns here. Let's keep continuing all the way up to the 20th amount. So the 20th amount that he puts in will be 750 times 1.08. He's put this in at the beginning of the year, so he's going to earn the 20th year's worth of, that 20th year he'll earn that 1 year's worth of interest on it. There's his amount for the 20th year. So the total amount that he has is adding up all of these. So it's this amount plus this amount plus this amount all the way up to the 20th amount. Do you remember what the trick was? I actually don't want to look at these numbers written from biggest to smallest. See, the powers start with a bigger power right through to a smaller power. I want to go from the smaller power to the bigger power. It makes life easier. So I'm just going to write it in reverse. So 750 is common. Let's take out 750 as a common factor. And now inside my square bracket, I have a geometric pattern. Now that geometric pattern has a value of A of 1.08 to the power of 1, which is just 1.08. Every term is being multiplied by 1.08, so that's my value of R. We're going from 1 to 20, so N is 20. There's 20 terms there. Just a refresher, that's our formula. So we'll have 750 multiplied by that formula because that formula is going to be applied to the square bracket. So it's 750 multiplied by A, which is 1.08, R to the power of N, 1.08 to the power of 20, take 1 on 1.08 minus 1. Put that into your calculator and he ends up with just over $37,000, rounded to 2 decimal places. Let's think about what he actually put in. He put in $750, and he put in 20 lots of it. So $750 times 20 lots works out to be $15,000. He put $15,000 and he got back over $37,000. That's not bad interest. He put in a smaller amount. It was for a smaller time period than last time, and the interest rate was a little bit less, but he still more than doubled his money. Let's try our third example and final example for this exercise. Well, a little bit different because we're putting $500 in, but at the end of each month of a year. So if it's only each month of a year, there's only 12 payments going in, or 12 months. Interest is paid at 0.3% per month. Well, this is monthly, and that's already per month, so that's good, but we need it as a decimal. 0.3 divided by 100. So 0.3 divided by 100 would give us 0.003. Let's find the total amount of the investment to the nearest dollar at the end of the year. Okay, so what's the first amount going to be? It's $500, 1.003 to the power of. Now this first payment went in at the end of January. So by the end of the year, it's only going to earn 11 months worth of interest because it missed the interest for January because he put it in at the end of the month, not the beginning of the month. So there's my payment for the amount of money earned for my first $500 amount. The second $500 amount, still $500, still the same interest, and he's only going to earn 10 months worth of interest because imagine at the end of February, there's only 10 months left in the year to earn your interest. The third amount, same pattern with only 9 months worth of interest. Let's go through to the end of the year, the 12th amount. Well, he puts in $500, but he puts it in at the end of the month. So he puts it in at the end of December. So how much interest will he earn if he puts $500 into the account at the end of December if he's taking the money out at the end of the year, which is also the end of December? He'll earn no interest on that amount. So it's just 500 times 1.003 to the power of nothing because he got no month's worth of interest. He'll just get the $500 back. What's his total amount of money? Well, it's A1 plus A2 plus A3 up to A12. So it's that amount plus that amount plus that amount all the way up to that amount. What was the trick though? Let's write them from the smallest power to the biggest power. It will make life easier. I can see a common factor of 500. Let's take out the common factor. Now I've got a set of square brackets, and inside the square brackets is a geometric pattern. So what's A? Well, A is 1.003 to the power of nothing, and anything to the power of nothing is 1. So A is 1. Every term is being multiplied by 1.003. Even though we only go up to the power of 11, there are still 12 amounts because the first amount was to the power of 0. You get from 0 up to 11, that's 12 amounts. And you can see I've got 12 amounts because I've done it up to 12 amounts here. So n is 12, and there's a reminder of our formula. So it will be 500 multiplied by the formula, which will add up this geometric number pattern in the square bracket. So A is 1, R is 1.003 to the power of n, which is 12. Take 1 on 1.003, take 1, put that in, and we end up with $6,100 to the nearest dollar because the question said find the total amount of the investment to the nearest dollar. Now, let's think about this for a second. He's put in $500 12 times. 5 12s are 60, so it's $6,000 that he's put in, and he's got $6,100 to the nearest dollar. He actually hasn't earned much because he put in a small amount. It's only over 1 year. The interest rate is quite low, 0.3% per month. You don't get a chance to earn a lot of interest unless you put the money in there for a longer period of time. So that's the process. Now it's time for you to try doing those questions. You have the remainder of this class and next class. Have fun. Bye for now.